With 2.6, this is the first half of 2.6. 2.6 is all on graphing special types of functions, different types of functions, and this is specifically on piecewise defined functions. So I will just say to start, piecewise defined functions are part of Algebra 1. I can't guarantee you all saw it because I know you may not have all had the same Algebra 1 teacher. You maybe weren't all in the same class. Some of you might have been in Alex for Algebra 1. Some of you were in the classroom. So I can't guarantee all of you saw it, even though it should be part of Algebra 1. So if you didn't see it, it should have been part of your class. I teach it as if you haven't seen it. So if it doesn't seem like review, that's okay, because I'm teaching it as if it isn't anyway. And then if it does seem like review, awesome. But piecewise defined functions, ultimately you want to not only be able to graph them today, but the third example we're going to do is actually writing a piecewise defined function if you're given a graph. So how they are defined: a function that's written using two or more expressions is called a piecewise defined function. So it's basically made up of different pieces. One thing I want to explain before I talk about what is indicated up here is in this function, if you just look at example 1, so the equation of what a piecewise defined function looks like. So it's f of x equals, which again, remember f of x is the same as if we said y equals. The first column, the x minus 2 and the x plus 3, those are expressions in the piecewise defined function. So it's really two separate equations. It's y equals x minus 2 and y equals x plus 3. And then in the second column, these are the domains for each expression. So the expression x minus 2 is only defined on the domain if x is less than -1, and then x plus 3 has a separate domain. So on the expressions, I also want to specify these are both linear expressions, and all of the ones you're working with today are all linear expressions. So these are all written in the form mx plus b. So it's y equals mx plus b, but your y equals is over on the very left side of the function. So just so you know, those expressions do have a slope and a y-intercept. What it also says on the top, and I'll talk about this when we get into example 1 with graphing it, is on the graph of a piecewise defined function, you are going to notice at certain points there's closed dots, and at certain points there's open circles. So they have the same meaning on a coordinate plane as they do on a number line. If you see a dot, it indicates that the point is included in the graph, and if you see a circle, it indicates the point is not included. So we'll have to determine where to use circles and dots, but you'll see both. So looking at number 1, we have that piecewise function. We are going to graph it, and then we're also going to identify the domain and the range. So I know I said these are the domains here for each piece. The domain we're looking for in the end is the domain of the whole function. So we're not just copying these both down for the domain. So how I typically show how to graph these, I've kind of shown it differently at different times, and this is a way I think most students can more easily understand, but at any point, like any lesson, if you have questions, let me know. Is I show to graph each of your expressions separately, so making a table for each. So like I said, this really means I have one equation, y equals x minus 2, and then I have a second equation, y equals x plus 3. And I'm just going to put next to these what their domains are. So the first one, the y equals x minus 2, this is for x values less than -1. And the y equals x plus 3, this is for x values greater than or equal to -1. And I'm going to make a short xy table for each graph. And this is how I fill in the tables. So in your two domains, the x is less than -1, x is greater than or equal to -1, whatever this value is, the endpoint of each of those inequalities, that should be the first x value that is substituted into both equations. So the first x value in each of my tables is going to be -1. Even though for that first domain it says x values are strictly less than -1, I still put -1 in there. So whatever those endpoint values are, those get substituted into both. They should be part of both tables. And then the remaining x values, I just go off of the inequalities. So the rest of the x values in that first table should be less than -1, so I could plug in -2 and -3. And the rest of the x values in that second table should be greater than -1, so I could plug in 0 and +1. So they share the x value -1. All of the other x values between the tables should be different. They should not be shared. Then I can find the y values in each table. So for the first table, I'm substituting those three x values into x minus 2 to find the y values. So if I put -1 in, -1 minus 2 is -3. If I put in -2, minus 2 is -4. And -3 minus 2 is -5. And then for the second table, now I'm substituting those into x plus 3. So -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. And now when I graph these, I'm going to graph each table separately. But this is where the circle and dot part comes in. So between these first points in each table, because they have the same x value, one of them is going to be an open circle, one of them is going to be a closed dot. They cannot both be dots. If they're both dots, it's not a function. Because you'll see when we graph it, then it wouldn't pass the vertical line test. So to figure out which one's a circle, which one's a dot, you look at your inequality. Because this first one is strictly less than -1 and it's not equal to, this is going to be an open circle on the graph. So you determine circles and dots the same way you determine them on an inequality. And then for the second one then, because it's greater than or equal to, that would be a closed dot. The remaining points, those you just plot as normal. So you would plot them as actual dots. So it doesn't mean that every point in your first table has to be a circle, just that first point. So now I'm going to graph the first table first. So I'm going to put an open circle at the point -1, -3. And then I'm going to plot -2, -4. Again, that can actually be a dot, and -3, -5. And now when I draw this piece of my graph in, I just start at that open circle and I draw my line through the other points I graphed. So that's going down and to the left with an arrow at the end, but I do not extend it through the other direction. So that's because if you take a look at this, so that first endpoint would be at the x value -1, and it's only for values of x less than -1, so it's just to the left. The second piece then, I'm going to plot the endpoint, the -1, 2, and that's a closed dot. And then I can plot 0, 3, and 1, 4, also as dots. And to draw this piece in, I start at -1, 2, and I just draw a line through the remaining points I graphed, so this one is going up and to the right. And I do not extend it the other direction. This is what the piecewise graph looks like. Questions before we find domain and range? Okay, so then one other thing, because again, I want you to know why we're doing things and not just how to do it, but again, the reason for the dot and the circle is, notice if I drew a vertical line through -1, I still pass the vertical line test because this is an open circle. It's representing an endpoint, but it's not actually included as an ordered pair. So that's why you need a circle and a dot. If both were dots, it wouldn't be a function, and we know it should be. So then to find domain and range, domain, remember, is your set of x values, range is your set of y values. And when you write these out, you don't need to write set builder notation, you don't need to write interval notation. You certainly can, but I'm not requiring that from here on out. So for the domain, again, the domain of the entire function is what we're looking for. So if I look at the two separate domains I have given in the function, this says x values that are included are less than -1, equal to -1, and greater than -1. So hopefully when you think about that, that means every value is included. Less than -1, equal to -1, greater than -1. So it includes everything. So the domain is all real numbers. So you can make the all real number symbol. You can actually write out all real numbers. And the domain, I would say most of the time is all real numbers. It's not always, so don't just get in the habit of filling that in as all real numbers every single time. It's not always that way. Range, now this is going to be different for every example because it depends on what your graph looks like. So to find the range, I typically look at the graph. I'm looking at the y-axis. So because I have these two pieces that are separated in between, like there's a gap in between the two pieces. The first piece, the topmost y value is -3, and it extends down. So that means every y value that's less than -3 is included. The top piece starts at 2 and extends up, and it includes 2. So I have 2 and everything greater than 2. So my range is going to be y values less than -3, and it's strictly less than because of the open circle, or y values greater than or equal to 2, because I am including 2 because of the dot, and I'm also including everything greater than 2. And because the graph doesn't exist between those two y values, that's why there's that gap in the middle. And that's why I need two separate inequalities to write out the range. Questions on that? So it's important when you are working through your own examples that if you have questions at any part of the example, but like I said, range is always going to be different. It depends on what your graph looks like. Please ask. Whether you ask me or ask somebody else, just make sure you understand how to find it. And then we'll look at example 2. So I want to go through another graphing example. This one has 3 pieces. So our graph is going to have 3 pieces. We're going to be making 3 separate tables. So if I set this one up, my first piece, again, the f of x equals is just like y equals. So I have one piece is y equals -3. Bless you. This is for x values less than or equal to -4. My middle piece, my second piece, is y equals x. And this is for x values between -4 and 2. And then the last piece is y equals -x plus 6, and this is when x is greater than or equal to 2. So I'm going to, well, I'll make my tables here. I'm going to make a table for each of these. And again, I first look at the endpoints in the inequalities for those individual domains. And those are the first values that get substituted into my tables. So in my first function, the first x value I plug in should be -4. You just want to set it there. In my second table, I have 2 endpoints. I need to plug both of them in. So I need to plug in -4 and I need to plug in 2. And then my third function, I just have the one endpoint I need to plug in 2. And then I can fill in the other x values that I should plug in. So again, in the first function, the rest of the x values should be less than -4. So I could do -5 and -6. I don't really need to plug in another value into the second one because as long as I have 2 points, I can draw that piece of my graph. But if you wanted to, just make sure any other x value you plug in should be in between those two numbers. So for example, I could plug in 0, because that would be in between them. And then for the third piece, my other x value should be greater than 2. So I could do 3 and 4. And then we'll find our y values. So in the first table, I have nowhere to plug in x. This just says my y value is always -3. So all of these y values are -3. In the middle piece, this says my y value is just equal to whatever the x value is. So when x is -4, y is -4, x is 0, y is 0, x is 2, y is 2. And the third piece, I'll actually need to calculate when I plug them in. So if I plug in 2, I have -2 plus 6, so that's 4. If I plug in 3, -3 plus 6 is 3. Plug in 4, -4 plus 6 is 2. And now I'm ready to graph these. All right, so if we graph the first one, first of all, the -4, -3, that first endpoint, should that be a open circle or a closed dot? Closed dot because of the less than or equal to. So -4, -3 is a dot, and then I can also plot -5, -3, -6, -3. So I'm starting at my first endpoint, and this is extending to the left, the horizontal segment, or horizontal ray, I guess, officially. The middle piece, both endpoints are going to be the same. Should they be circles or dots? Open circles. They are not included. They're just representing endpoints. So -4, -4 is an open circle. 2, 2 is an open circle. And this is where I was saying I didn't really need to plug in another point because really all you're doing is you're connecting these to make your line segment. So don't go through either point. You're just connecting them. But I can plot 0, 0 in the middle too. You see that the line segment would go through it anyway. So they're just connected. And then the third piece, that first point 2, 4, should that be a circle or a dot? And both. It's greater than or equal to 2, so it should be a dot. So at 2, 4, I should have a dot, and then 3, 3, 4, 2. So starting at 2, 4, and then this part is extending down and to the right to go through those other points. And you can always double check. So if you notice at the x value -4, I do have 1 dot, 1 circle. At the x value 2, I have 1 dot, 1 circle. They can both be circles, they just can't both be dots. So that's where you'd have to check for. All right, that's the graph. Domain for this one. What do you think the domain is? That would be the range. Yes, so range is going to be all y values less than or equal to 4. I'll explain the range more. Anybody have an idea what the domain is? All real numbers again, yeah. If you notice, we have those breaks at -4 and 2. That's kind of where each domain kind of switches to a different expression, but every value in between and outside of those values is included. For the range, what I want you to notice is this topmost point is at the y value 4, and it is included. And then that piece of the graph extends down forever. So these other two pieces of the graph, those y values are all included, even from this line. So every y value is being used that is less than or equal to 4. Above 4, the graph doesn't exist. So that's where I'm saying the range is always different. It's not always, you know, two separate inequalities. Sometimes it is all real numbers. So just make sure you ask if you're not sure. Okay, questions? Okay. Then I know there's 2 examples on the back. I just want to go through example 3 and then leave time for you to work. But both of these, so like I said, not only should you be able to graph, you should be able to write a piecewise function if you are given a graph. So this is now working backwards. I am giving you the graph, and I want your answer to look like this. You're writing the function. This is how I typically start. I first look to see how many pieces my graph has. So this graph has 1, 2, 3 pieces to it. So when I set this up, I'm going to say f of x equals, and then draw a brace as best as you can. And because I have 3 pieces, I'm going to have 3 expressions. So I just put blanks here, and then I'm going to fill in those blanks. So I have 3 expressions with 3 domains. So it's always the expression, if, and then the domain for that expression. And the domain, those are your inequalities with x, what x values are included. Also remember your expressions are all in the form, well, y equals mx plus b, but remember your y equals is the f of x equals, so you don't need the y equals here. So what that means is if we can look at each segment on the graph and pick out what is the m, what's the slope, and what is the b, the y-intercept, then you can put that together to write those 3 expressions. So let's look at this leftmost piece, the one that starts up at that circle and extends down into the left. First of all, what is the, I'm just going to draw an arrow to it to label, what is the y-intercept of that graph? Y-intercept is where it crosses the y-axis. Where does it cross the y-axis? At 3. So the b value is 3. So I'm going to have something plus 3. And then how do you find slope from a graph? Rise over run, yep. Make a note of that. I have a lot of students who start to just use, they pick out like an x-intercept or an x value from the graph and just use that as the slope. You actually have to find your rise over your run, so sometimes it is a fraction. So I could go from that y-intercept up to that end point, and to go from one point to the next, I have to go up 2 and over 1. So my slope would be 2 over 1, or just 2. So if m is 2, b is 3, my expression is 2x plus 3. Okay, so we'll do that to find each of the 3 expressions. Before I find the next expression, though, I want to find the domain for this piece. So to find the domain, you have to look at the endpoint and figure out what the x-coordinate of your endpoint is. So I could follow that endpoint to the x-axis and see that the endpoint is at the x value 1. And then it's everything to the left of 1, which would be values of x that are less than 1. And it's strictly less than because it's an open circle. So this domain would be x values less than 1. Questions on how I found that? I have two other pieces, but again, either right now or when you have time to work, please let me know if you're not following something I'm saying. So now for the second piece, that's this little short line segment that's here. Now, the way this is graphed, it doesn't actually cross the y-axis. So when you're finding your y-intercept, just picture that if you extended this to cross the y-axis, where would it cross? That's what you want to ask yourself. So if you extended this line segment, where would it cross the y-axis? At 2. So the y-intercept, if this was extended, would be at 2. And then the slope, again, rise over run, from one point to the next, I would be going down 1, right 1, or up 1, left 1. So it'd be -1 over 1 or 1 over -1, so just -1. So m is -1, b is 2, so the expression is -1x, or just -x plus 2. And it does have one endpoint at the x value 1. The second endpoint is at the x value 2, and they're both dots. So the x values are between 1 and 2, and they're both dots, so they're included with the or equal to. So just note how that's written, same way it was written in chapter 1 with those component inequalities. The way this is read is x is, this is read backwards, greater than or equal to 1 and less than or equal to 2. Or again, thinking of it as x being in between. And then the third piece is that horizontal segment here. So if this was extended to cross the y-axis, where would it cross? At 3, yep. And what is the slope of a horizontal line segment? Or just a horizontal line? The slope isn't 2. Slope is 0 because there's no rise. There is a run, there's no rise, so it's 0. So I could write 0x plus 3. I don't need the 0x, I can just put 3 because 0 times x is just 0. And now the 2 is for the endpoint. So the endpoint is at the x value 2. It's everything to the right of 2, which is greater than 2. And because it's an open circle, it's strictly greater. So x is greater than 2. And that function, that is your answer for that type of question.